All right, folks, welcome to Pebbles Rebels. And as always, I'd like to start by acknowledging the traditional custodians of the land and pay respects to elders past, present, and emerging. So before we start, you'll probably have noticed that Kira is actually missing this week. That is because she is down with a sinus bug, so she won't be with us. But we do have a very special guest this week. We have Brian Shaw, who is not only a member of the NF community, but he's also a retired school teacher. So, in the spirit of that, the three of us would like to say,
Evening,
evening, Mr.
Mr. Shaw.
Shaw.
Hello, children.
Yes. So, just so you know, Brian actually has a background in science. So, he did a major in chemistry with a sub-major in biology, which makes him a very, very, very smart man.
Thank you, but not all that smart. But worked hard.
So,
Worked hard. I've got NF, so I worked hard.
so the really cool part is he's actually going to take us through a bit of the science behind NF today, which we've all been dying to learn because there's lots of stuff that we actually don't know and haven't been able to explain on the podcast. So that's why we've brought Brian in, and and over a couple of episodes, Brian's going to take us through the science of NF1 and NF2 and, pardon me, schwannomatosis.
Try my best.
Yes. So, Kirsty, would you like to take over and get Brian's screen sharing happening?
Yep, so we'll just organize a little PowerPoint. Hopefully our Zoom works. We'll see.
Yeah. So, those of you
See how,
listening on audio, you can jump across to YouTube, I think. Is it YouTube, Kirsty? And you can see the slides if you want to play along at home.
Otherwise, Brian will still talk to them. So hopefully the talking to them will be enough information for you to understand what Brian is talking about. All right, I believe I pressed allow. So hopefully it works.
okay, let's see how all this goes.
Fingers crossed.
And fingers crossed, I haven't done this for a long time. Okay, can you see my screens?
Yeah.
Can you
Yes, we
see this?
can.
You can. Excellent.
I can't see anything. I can
Now,
only see the three of you.
Oh,
It'll probably be in another window.
I'm just using my iPhone because I don't have a computer.
Oh, that could be why. All right, so
Okay, no, that's good.
Bernie gets to fly blind.
can you see that now?
Yes, we can.
All
Neurofunk.
righty. Chromatosis, a genetic disease. Now,
Yes.
one of the things that I did was during my life as 45 years of a teacher, I gave talks to my year 11 and 12 biology classes, or the other teachers' biology classes, about the genetic disease because it was in the syllabus. And that's how I started raising awareness of NF in the schools that I've taught. So I was pretty privileged. They were good kids. Even all the kids I taught were pretty good when I did this. So let's see. We know this one. The podcasts have covered some of the earlier slides. We know NF1 affects about 2.5 to 3,000 people across the whole world. NF2 about 1 in 25,000, and NF2 schwannomatosis 1 in 25,000, and schwannomatosis about 1 in 40,000. So in Australia, we've got about 15,000 people. So let's have a look. This is how I did my year 11, 12. So it might get a little bit technical. If it does, ask questions anytime, guys. I'm very happy. It's a very common genetic disease. It's wide variety, so we know all that stuff. And about 40%, 50% of people will need some medical attention, probably some surgery, some major surgery, and stuff like that. And one of the things that I find very frustrating is that it's impossible to predict who will be affected and how much, how severely they will be affected. During my teaching life, I probably would have taught about 5 or 6 kids with NF. And once they found out I had it, it was a little bit of a different relationship, which is pretty cool. Some were much bit closer, if you like, and some just went, "Oh, I don't want to know about it." But at least I've done for me, I think I was a good role model as a person who can achieve with NF.
Just quickly on that
One
topic
of the things,
as well, if our listeners have any questions that aren't covered in this podcast, feel free to reach out to us either by commenting on the podcast episode or messaging us through our Instagram page, and we'll happily organize to get an answer for you.
absolutely, feel free. I've had a whole heap of questions asked, and some of them are just so delightfully funny. It's ridiculous, and I love every bit of it. I think it's great. One of the things that was really interesting when I first started teaching in our science textbook in New South Wales that I was teaching from, it had NF in there, but it also had the relationship between NF and Elephant Man,
Yes,
and
Oh
that was
yes.
really
I've had that question
interesting.
a few times.
And it was only in the mid 80s that that sort of was proven elsewhere. But as a kid, when I was growing up, it was really lovely to say, "Oh, what have you got?" And I'd say von Recklinghausen's disease, because that was the original name for it, because of the doctor in Germany that found it recognised in 1882.
Actually,
Um,
that what you said about elephant man's disease, that is still a pervasive thought
thought,
even
yeah,
now in 2026. So, there are the occasional person who goes, "Oh, isn't that like the elephant man's disease?" And I'm like, not really.
let's say Elephant Man disease is now Proteus syndrome, I think it's called.
Yes, correct.
Something along those lines. Okay, symptoms, some cafe au lait stains. We probably know about that. The leash nodules, and this image is from Kira, who sent it to me, and it's of her eyes. So I love that bit of linking there. And those are the leash nodules that you can see the little bump, the coloured bumps there, and that's an indicator. Some cafe au lait stains, some freckling in the armpits that come in, and obviously our lovely lumps. They're not mine. That's just from the internet somewhere about 12 years ago when I was first doing all this. Um, there are some photos. The top left hand is me as a little kid when
No.
I was about 5. Um, it is a very cherished little photo that I've got. There's other family members there, um, but you can see my eye is quite droopy even back then. Um, so there,
I have a
and the lady
question
down
for
the
you.
bottom right hand corner, I know, and I can't remember who it is. I think she is a New South Wales lady. I'm pretty
Yeah.
sure.
So, how old were you when you were diagnosed, Brian?
Probably around about 18 months, because that's when I had my first operation.
Yeah.
And if you like to know the year, it was about 1959. So
No.
that's quite a long time ago as regards having my first operation. Um, and I was in and out of hospital probably at least once a year till I was about 12 or 13.
And
Um,
did you
just
inherit it or are you spontaneous like me?
I am spontaneous as far as I'm aware. It's we have a family history of some interesting things happening, but nothing's related to NF as far as they were aware.
I will jump in at this point. I don't remember if you did cover that in your first slide, but so NF, you're probably going to cover it in a later slide that NF is an autosomal dominant condition. So
And yep, yep,
yeah, so
yep, it's
I'll
all. Yeah.
bite my tongue.
Leave that for a while. Yep. So it was a spontaneous mutation. Um, some family sad news. My eldest brother, when I was in year 5, so that would have been when I was about 11, 12, passed away because of a brain tumor. at that point, and that was 1968.
Yeah,
And my mum and dad said, "Is that related to what Brian's got?" Because they obviously were worried that
of
that might the
course.
same thing happen. And at that time, the doctor said no. So I have got no evidence that it was.
Yeah.
There was just, again, you're dealing with almost 60 years ago. All right. So sorry. Again, some fairly basic symptoms that the doctor should be looking out for to diagnose us. All right. The family history of the disease, which luckily I didn't have, larger than average head, which we know about, shorter stature, which at least I am. I know that I'm pretty, yeah, we're not tall people, generally speaking, considering the height of my brother and sister were much taller. Specific learning difficulties. While I had a university degree and I did pretty well, there was lots of things that I had trouble with even going through there. Um, and at that point, learning difficulties was not an identified issue of NF. I had trouble writing essays that I had to do for the education and getting my thoughts expressed properly. And it was so frustrating that, you know, they'd write back and say, but you haven't said this, or you've left an apostrophe off a possessive or something like that. And they'd be marking you on that rather than trying the content. But
And
that's how we
did you find that teachers were understanding of your learning difficulties, or did you find that they were um, harsh about them?
in university, they were very harsh, generally speaking. Although, because I was doing chemistry, we had smaller classes, so it was much, much, much better.
Yeah.
Education was massive, so you sort of understood they couldn't really do much about there. And I had some delightful teachers of maths, and when I was doing the higher level maths, they were just fantastic. They were so helpful.
Yeah.
So that was really cool. So, yep. So, but yeah, I still have trouble. I'll stuff around. But yeah, okay. So, again, some fine motor controls. I'm just, that's me. Hypertension, got a bit of high blood pressure, and so on. Optic gliomas, luckily, no. And the itchiness of the skin. Okay, here are some things that we probably should get onto. As a genetic issue, um, we all have this in our cells. We've got chromosomes, and they contain the material that allows us to be us. So what we have are 23 chromosomes. We have 22 of them are what we call autosomal chromosomes, which are another name for our body cells, our body chromosomes. And we have a pair of sex cells, which makes us male or female, or some combinations, because if we don't get that quite right, those can muck up all our genetic as well. And the two main ones that we are concerned with at the moment are chromosome 17 and chromosome 22, which are the majority of the people who have NF. And I haven't been able to find out what chromosome pure schwannomatosis is on, but I think it's
I
22.
just had a quick check myself and it says 22Q.
Right, okay, which means the Q is a marker of where it is on the. Okay, so what the autosomal ones are going to be all through our system, and they are important for the production of all our proteins, all our chemicals, all our enzymes, all our hormones, everything, as well as the sex chromosomes. But if you have a look, they're all arranged in, if you like, length order. So number one are our longest ones, and 22 are our little ones. They're really little short. Okay, so this is where we then get on to our characteristics. There are two things that we need to know about the genes. Firstly, what, if you like, chemicals actually make them up, and what will be expressed. So those two are things that we need to keep in the back of our mind. And the words dominant and recessive often come in, and across some of the forums that I've been looking at, especially lately, get these two confused. NF is a dominant gene, which means if we have that gene, it will be expressed. And that's the key thing. The trouble is that because NF is so variable, it doesn't get expressed the same way on every single person. So if you don't have any lumps and bumps, if you don't have any, let's say, larger than head, or you don't have scoliosis, and you are looking normal, then people will assume that it's skipped a generation, where it mightn't be. You might have NF, but no other manifestations that are visible. Yep. Yeah. Yes, Yanu.
I'm on mute. Yes. So because it's dominant, that means like you can't just be a carrier of the gene, right? To then pass it on. You have to have it, correct?
If you've got one gene, and we'll look at it a little bit later, if you've got the one gene on the one chromosome, you have NF
Yeah.
regardless. It's just not hidden like a recessive gene is.
Yeah. Yeah.
The recessive gene, you need two copies of that gene for it to be expressed.
Cool.
NF, you'll only need one gene
Yeah.
for it to be. But the thing is, with NF, it's so variable, it just doesn't get shown
Yeah.
at times.
Yeah. Got
Okay.
it.
Does that make sense?
It
Yeah.
does.
Alrighty. Now, what causes it? Okay. Sorry, I have to have a drink. What happens is that our genes are made up of a series of chemicals in bunches of three, which I'll get onto a little bit later. Those genes dictate what chemicals are made to make our cells, to protect our cells, to control the development of our cells, and so on. And NF1 is caused by a mutation in what they call the growth factor that handles the development of what is called the myelin sheath. Now, that is the covering of our nerves. Every single nerve, basically, I won't say guarantee it, but every single nerve will have a myelin sheath, much like our insulation cords on the insulation on our electrical cords. What then that happens is that it controls how fast or how slow the development of that particular sheath going through as the nerve cell develops. In reading this, and this has changed a little bit, apparently there's over 1,000 different mutations in the NF1 gene that can lead to NF.
Wow.
Which is quite, I mean, even as a science teacher, I find that is just amazing that there's 1,000 different ways we can get NF
That probably
in
also
some form.
explains the different like how everyone with NF has a different sort of case of NF in a way.
Manifestation. Yeah.
Yeah,
Yeah.
that
Word. Yeah. Manifestation. So it's an interesting gene in itself, and the
Yeah.
number of mutations are interesting. And as we probably know, about 50% of the new NF1 cases come from a spontaneous mutation.
Mm.
Okay, so I'm spontaneous. Yanu's spontaneous. Bernie
Inherited.
inherited, and
inherited as well. Dad was spontaneous though.
there you go.
Here you go, 50
What a
50.
perfect sample. 50-50. So that helps.
And they believe
Okay.
my mum was spontaneous.
Yep.
And they think my grandfather's age because my mum was conceived when my grandfather was on the older side to have kids.
Yep. And that's a possibility too. And because it's autosomal dominant, people who have NF will have about a will have a 50% chance of passing the NF on to their kids. Now, I have three children, and my kids have always given me permission to talk about this. My eldest daughter hasn't, and she has two kids, and there's no sign of NF in those for the in with her children. So that's good.
I might be jumping ahead here, Bernie, but
Yeah.
as you said, if there's one parent with NF, there's a 50% chance. But we also know that if both parents have NF, it goes up to 75%. Do you have a slide to explain how that works?
Awesome. Yes. I am doing as I was asked. So let's have a look. Okay, here's a little bit better thing. We have the myelin sheath over here. Can you see my pointer?
Yes, we can.
Okay, the myelin sheath is there, and that's basically on the whole nervous system. And what happens is that the NF1 gene actually is the controller of the growth of those cells. And so what happens in the mutation, it's like the off switch. It turns off the control mechanism and therefore allows the cells to grow. So much like any other type of cancer, tumor type thing, that the growth is is contained.
I
Okay.
actually like to make the corny joke is with my NF is that's why I'm such a nervous person.
And I always like to be sure of myself. So, yeah. All righty. So the protein that is so important and what is about NF is our neurofibromin. That's the protein. It is normally a chemical that is a tumor suppressor. So it stops the growth, it slows the growth down. And that is if you like, the whole thing about NF. If we could sort of work out how that works, then we are on the road to some type of treatment, and it's getting there. Some of the newer drugs are getting there, which is really pretty cool.
Well, just a
Okay.
side note, I've heard from the Children's Medical Research Institute, they've got the information on how to stop the nerves growing, but they don't know how to get it delivered within the body. So that's what they're working on now.
So that, yeah, I mean, it's just amazing what's happened over the last 10 to 15 years. So we've got these chemicals not being produced or being stopped being able to be worked effectively within the cell itself or the environment. So that's basically the, if you like, the bugger that we're faced with. Okay, here is, if you like, our gene. Now, what is happening is here is where they finally located, and I can remember teaching it in the 80s. And I think it was just after I was married, and we were living in Goulburn in New South Wales in Australia. And I got a message from somewhere that they identified chromosome 17. And I went, wow, fantastic. And they've now located it to this particular point. And once they locate the position, they can start looking at the genetic sequence that is there. Now, that's
So,
where they identified it. And then the next step is to work out what the hell the genes are made up of.
so one more
Now,
question around the location, if we can jump back to that slide, please. So you know how you said that each person's NF is a little bit different. So does that mean that the location's a bit different with each person, or is it all the same location
going
and
to be
just different?
slightly different, but as far as I'm aware, um, the location is it's you're looking at a fairly specific part of it, but the location is quite spread.
Okay, so it's
So
kind of like you're in Canberra and I'm in Sydney and Kirsty's in South
Well,
Australia.
no, it'd be like I'm in Canberra and Kerry is in another suburb of Canberra.
Got it. Yeah.
Okay, so it's really that's the area that the gene for NF is located,
Got it.
and that is a long sequence of chemicals, which we'll get to.
Got it. Thank you.
Right. All right. Here is some of the stuff that we did in biology. You know, year 10, year 11 biology, etc. So here is the one parent who has NF, the other parent does not. Now, the way in which we do it in science was a Punnett square. Can you remember the Punnett squares?
I do.
No.
Okay, so this is how we do it. Let's say for me, being the father, I have NF, which means I will have at least one gene, one of the chromosomes having NF, and the other one having the recessive variety. And we do that by representing it as a big N for NF, which is dominant, and the little n for the recessive. My partner, who does not have NF at all, will have two little n's, which means she will then have the recessive gene on each of the two chromosomes. Remember, chromosomes are paired up, so they're pairs. So we do the Punnett square, which is just a little maths cross. So we have big N, little n for this one, and then little n, little n. And then in this one, we have big N, little n, whoops, and little n, little n. And if we count up the number of big N's, there are 2 occurrences out of 4, which means 50% chance. Okay? And that's how we've got the 50% chance if one parent has NF and the other parent doesn't. And if we have both parents have it, because it's the same basic thing, each parent will have big N, little n, and big N, little n. And when we do the multiplication table, we have 3 people or 3 possibilities that have the big N and 1 little n. And that means 3 out of 4, 75%.
Right. That
Oh,
makes more sense.
That makes way more sense.
And then that is why it's 75%. And obviously there's a last one. If one parent has both chromosomes, let's say both parents have had NF, then there's a likelihood that there'd be 100% chance of having the kids.
Yeah. Because I was going to say that top left-hand corner, there'd be 2 big N's. Ergo,
Yep.
100%. Oh, wow. That's wild.
And that's how you can, it is a relatively simple way of showing, hey, that's what it was. What annoyed me was when my wife and I went to a genetic counsellor to work all this out. For some reason, I did not know that NF was dominant. Otherwise, I could have done this all myself and saved $150 back 40 years ago. But it was worth it. And as soon as they said, "Oh, it's dominant," I went, "Oh, okay, it's 50%." But they were lovely anyway, so it was fun. So it was all right.
All right, I think what we
Okay.
might do is we'll
Now we know.
start the Zoom again because we've only got like 5 minutes left before it'll time out on us, and then we can go from slide 19.
What I've done is move forward a couple of screens because I think that will be a little bit better to do. And hopefully we'll see that. Yep. Can you see that one?
Yep. Can you just jump to the previous slide real quick, Brian, so we can sort of... Yep.
Oh, yes, of course.
There we go.
Okay. The effects on the person, we know it is widely variable between the families. I know my daughter didn't really have too much of an issue except with a plexiform on her leg as a young kid. But now that she's had 2 children, she's got getting some lumps and all that type of stuff, or lots more lumps than she's had. From small to large, we know about that, mainly on the peripheral nervous system, and the bugger of all ones, the plexiforms, which I don't like at all.
They are no
Because
fun, can confirm.
that's what my eye is all about. That's what the issues they had when I was a little kid.
Yeah.
And again, the skills I think the surgeons have changed dramatically over 60 plus years.
I
Okay,
actually have a
that
plexiform on my sciatic nerve, and it is literally a pain in the butt.
it would be, and I would not like to have them around there. Okay, cutaneous ones. Most of us know that they can be removed fairly easily, and the Sydney Clinic is pretty good at doing all those for us when we are booked in. And the plexiforms, because they're a finer tumour, then they're not going to be all totally taken care of. Um, One of the
Would you
doctors,
like to
when I was,
explain in lay terms what diffuse means, Brian?
it tends to move or be spread across, like one of the doctors that told me about the plexiform was they said it was like a rainbow cake for your birthday.
Mhm.
You cut a piece of rainbow cake and you have all those lovely colours in there, and you go and try and say, I want the pink colour out only, please, perfectly. And you're not going to have that surgery, even with the finest surgery these days, being able to do that. So the diffuse is basically like a fog. It's it's not everywhere, but it's not easily contained or confined.
Thank you.
Does that make sense?
It does make
Absolutely. Yeah.
sense.
Okay. Now for me, especially as a young kid, you have to be help. You just have to be positive as best you can. And I was very lucky throughout my teaching that it was only in the last few years that the kids have become a real pain in the butt at times. Only a few of them still, but it was a little bit more nastier coming in. I don't know. Maybe I was just getting old and cranky.
Mm, I mean, I've
Different generation.
so
Yeah, could be. Could
uh,
be.
yeah, I think you're right, Benny. I think it is the generation.
But it's just it was a different feel sometimes. Okay. Now, so this is going to be a leap a little bit more above. This is more aimed at the year 12s rather than the year 10s on the genetic scale, on the technical scale. Okay, it's a gene mutation on chromosome 17 for NF1. But how does that happen? Okay, what we've got now is the technology to actually identify the firstly the chemical sequence or the gene sequence
Mm.
of these things and identify the mutations that actually are occurring. Okay, so firstly, I went too far. Can't see what that is. Okay, chromosome. What the chromosomes are made up of are units called or thing chemical called nucleotides, and there are 4 nucleotides that make up every single gene that we've got. A series, and they're called, for simplicity, GCAT. Okay, on the DNA. A group of these, a group of 3 of these nucleotides is called a codon. And those codons act as a code for what the development of what we call amino acids. And they're essential for life. The amino acids are really important. And then the reason being is they make up our proteins. So the amino acids make up our proteins make up our muscles and body and everything else. And it all comes back to the nucleotides and the sequence of those. So, and this is in any living thing. It doesn't have to be us. It can be any puppy dog, bird, protozoa, amoeba, etc. So we've got a DNA strain, which is our lovely double helix. This is one half of it. And we have this set of 3 nucleotides. That set of three would be a codon. That may then make a particular protein. The next set would make a different protein. The next set will make a different amino acid, and so on. So we've got that type of sequence going along, and these are huge, if you like, in terms of sometimes 1,000 or so of these nucleotides in a chromosome. Okay. Now, what type of mutation happened? Firstly, what is a mutation? It's a change in the way in which the nucleotides, I wish I could say that now, are sequenced. And they occur basically three ways, depending on your point of view as regards reading the literature. Things are called point mutations and point deletions. I've grouped together. To me, they might be basically the same thing, especially at this type of level. It's certainly not a university level. And then there's things called frame shift mutations. Now, the two terms make some beginning sense. If you think about the point mutations or the point deletions, guess where they occur? One point. And then what do you think a frame shift mutation might be? It's shifting them somewhere. Yeah? Sort of makes sense?
It does.
Okay. Okay, here is a thing where we talk about point mutations. Here is what they call a reading frame. I like it because I'm a tech guy, I'm a computing guy, computing technology. So you're looking at a reading frame, which is like a series of data points. So here is our codon here, CAT, 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 and so on. That is our normal sequence of our chromosome, of our nucleotides, and that particular sequence will then make a particular protein. Okay? Here is what happens here. We have a point mutation. What then generally happens is that one of the nucleotides change. And can you see the difference? Which is the G.
The G.
The G is different. And as soon as you get that G being different, that is a set of different code for a different sequence of proteins or some useless protein or some useless chemical. And so we've got this happening, and we can see that we've got some abnormality coming through and causing some different protein or chemical to be produced. So we have in a point mutation the same number of nucleotides, but one is different. A point mutation or a point deletion basically, has one thing being deleted. And it stuffs up. It's like a word being deleted. Like I used to leave out a whole lot of things when I was writing notes on the board. And especially my seniors, who I'd love very much because they were fantastic. They'd put their hand up and say, "Mr. Shaw, you've left a word out." Yeah, thank you. And I take that as like a point deletion type thing. You've left a word out. It doesn't make sense. One of the words I left out so often was the word not. And I'd be doing something and they'd put up their hand and say, "Do you mean not doing this?" etc. And I go, "Oh yeah." So that's that type of situation there. So again, this disruption in the gene sequence really stuffs up things with the thing. Again, something a little bit just interesting maybe. Some of them are what they call silent, and it doesn't bring any change. It's just not affecting. I love this word, this missense. When I first saw it about 10 years ago, I went, "Oh, missense." The altered codon, which is the sequence of three, results in a different amino acid. And the last one is nonsense. Now, what they mean by a stop codon is meaning that it will stop producing a particular sequence of the chemical. And here is this frame shift. Now, if you have a look closely here, that we will get a shifting of the sequence. So here is what we call the inserting of a particular nucleotide. The T is being inserted. That means that the rest of the sequence is technically correct, but the reading frame, which is 3 each time, has been shifted. And as soon as that happens, we get a different protein amino acid type produced. Just sort of get that? So it's just these shifting, deletions, insertions, everything else happening. And it's like leaving a word out or a letter out in a word and having to make it up. Now, our brain is pretty cool. I could give you a slide with a sentence of a well-known, or even not a well-known saying with letters left out, and you'll be able to make an interpretation of it. But give it to some, let's say, other language person, they wouldn't have a clue because they wouldn't be able to use those skills that we've developed. Okay. Interesting from this point of view, about 90% of cases of NF are reducing to point mutations, so I read. And another little interesting fact is NF1 patients have about a 5-fold increase risk for cancer and maybe a 2,000-fold increase for nerve-based tumours, malignant one. But again, that's fairly loose type stuff. That was done a couple of years ago, so I'm not too sure about the developments from there. Okay, here we go.
Right.
Here's my animation. Hopefully it works.
Can we just pause here for a second?
Yep.
Bernie?
Yep, sorry, I'm just going to go.
Okay,
So,
mate.
thank you so much, Brian, for tonight.
Pleasure.
So I've got to leave early. I've just got super early starts at work for the next month. So, yeah. But thank you so much for your time. Hope you're on again next time.
I'll try.
Okay. Good night, ladies. Good night, Brian.
Thank you, Bernie. So
now, this is what
for those of you listening at home or on audio, Bernie's just jumped off, so we're going to continue with just Kirsty and myself. So go ahead, Brian.
Okay. Now, here is my attempt at awesome animation. What actually happens is it's like the old lock and key type thing that you may have been taught at school.
Yeah.
Here we've got on the bottom left the normal NF1 protein.
Yeah.
And what normally happens is the protein that the NF links to is, let's say, square shaped. So it will link in like that. All perfect, it fits, and it's lovely, and it works. And the next one is that the mutated NF protein, the neurofibromin that suppresses the cell growth on the Schwann cells, has been shape has been changed. And it's like this. So is it going to fit in? No, it can't stop that growth. So therefore, it will then it doesn't fit, it doesn't work, and therefore that reaction, that joining, that mixture just gets really stuffed up. Okay. And this is ending up. I found some support organisations because I thought, I better put something out for if in the most likely case people from overseas are looking. Here are some of the support organisations that you can find across the world. I know I taught in Singapore.
I
taught in Singapore for
our link tree for people that are listening online, as we know that some of you come from near and far. We've seen that we've reached the UK, US, Zimbabwe, Japan. So we will put the links that are on this slide also into our link tree so it's easy for you to access.
And
Yep.
I will also add it to my personal one as well, because one of the biggest questions I do get, sort of in my personal NF ambassador sort of channel is parents from all around the world looking for support in their country, and I didn't
Yep.
have those resources at my disposal, so now I do. Thank you for that, Brian.
It's my pleasure. I mean, it was quite interesting because I know I belong to a NF1 group from Ontario, and they are really very, very active, proactive. They're
Oh,
fantastic.
amazing.
So, anyone listening from Ontario, I think what you put up and people share is fantastic. But that's about it. Any more questions? That's for NF1.
Yes, thank you so much, Brian. We really appreciate it. This is a really in-depth thing, and I don't know about Kirsty, but for me, I never learnt any of this in-depth stuff about my NF. For me, I only learnt it at a very sort of like at a very shallow level. So this is really cool that you've done this. And hopefully
Thank you.
it'll help other NF warriors,
And I'm happy to take the
understand.
questions. So anything that's posted back, let me know, and I'm happy. But let me just preface it: it is very basic. It's not always perfect. There's probably going to be errors in there that I might have said something that's not quite right, but most of it should be generally pretty okay.
Sure. Cool. So we'll just stop the screen sharing now
Yep,
and
I
we'll
can do that.
wrap up. Thank you everyone so much for listening. Kirsty, is there anything you'd like to add before we wrap up?
I think just keep an eye out for future episodes as we'll keep diving deeper into different parts of NF and have different guests. And yeah, we're just really excited to take this journey wherever it leads us, really.
Yes,
Absolutely.
and Brian's going to take us through NF2 next time. We have him on and
Cross
explain
my
that
fingers.
side of things. And we will, and as I've explained before, or as we've all shared before, all four of us on the main podcast, we've all got NF1. So we are going to have a guest who has NF2 and interview them about their experiences living with NF2, because it is vastly different from NF1, but there are still a lot of similarities, tumors being one of them. Um,
And I think on that note as well, if you're someone with NF, no matter what type, sing out to us, reach out, whether that's through email, socials, however that might work for you, and we can work out a way to have you come on board if you're keen to jump on for an episode or even like a mini episode.
Yes, we would love to have you on board. So if you'd like to sort of, follow Brian's footsteps and, join us on the podcast, please reach out and we would love to have you on board to join the rebellion.
See you on the flip side.
Thank you.
Thank you, everyone. Thank you again, Brian. Bye, everyone.
Pleasure.
Bye.
Take care all.
See you.
Yeah, bye.